top of the bat looking smooth and Sean-esque. And there's the new trick he just learned, frontside double cork 1080. Oh yeah, I learned that one 2 days ago. Backside 900. And into the cab 1080. Now that'll get him into the finals for sure.
Hey, Algebra 2 students. All right, you just watched a video about snowboarding, and there was purpose behind that. I heard them say things like 1080 and 900, and I hope you caught that too. So 1080, 900, what did that mean? So you're right, 1080 meant that he made 3 revolutions, and 900 was 2.5. Okay, so these revolutions, this language 1080, 900, 360, 180, it all comes from degrees in a circle and something that we call angles of rotation, which is what we're going to be learning about today. There's a lot of vocabulary involved when we're talking about angles of rotation. I'm going to explain these words, but you'll probably want to pause this at some point and jot these down. I've also attached to our 13.2 folder a Quizlet that has flashcards so you can practice these words. It does have the words for the whole chapter though, so you will notice some things that you aren't sure of, but you could just pick and choose what you're practicing for right now. So first one, what is standard position? It's an angle whose vertex is at the origin and one ray is on the positive x-axis. Let me illustrate that, but I drop my stylus. Okay, I'm back. So let's break that down. Okay, an angle whose vertex is on the origin, so that means the vertex is right there at 0, 0. Okay. One ray is on the positive x-axis, so one ray of your angle will be right here, and then the other one can be anywhere else, okay? It could be an obtuse angle, it could be an acute angle, but as long as we've got those two things, that the vertex is at the origin, and then we've got this positive x-axis here, you're good to go. The initial side is this first side that's on the positive x-axis. The terminal side is the side that is not on the positive x-axis. We have positive and negative angles of rotation. Okay. When we rotate counterclockwise, okay, we are rotating in a positive direction. When we rotate clockwise, we are rotating in a negative direction. The way I remember which way is positive and which way is negative is we're always going to be starting right here on this positive x-axis. And we know that if we move up, we're moving in a positive direction. And then we know if we move down, this is where we've got negative values on our coordinate plane. So that's how I remember. So if we move up first, that's positive. If we move down first, it's negative. Last vocabulary word here is what is an angle of rotation? It is an angle formed by rotating the terminal side and keeping the initial side in place. If the terminal side is rotated counterclockwise, the angle of rotation is positive. If the terminal side is rotated clockwise, the angle of rotation is negative. So all these pictures you've seen right here on this screen have all been examples of angles of rotation. Okay, it's just when we start right here on this positive x-axis and then we create an angle from there. Okay, so we're going to start by practicing drawing these angles of rotation. So we're going to draw an angle with the given measure in standard position. I encourage you for every single example we do today, you take the time to draw it out with me, okay? So everything will start on a coordinate plane and we will always begin on this positive x-axis right here. So the first one is 320 degrees. So you're going to need to be reviewing that if we go right here, this is 90 degrees, then we have 180 degrees, 270 degrees, and then back here to 360 degrees, or when we started it was at 0. So we're going 320 degrees, which means we're going all the way around 90, 180. Oh, this is not turning well. 90, 180, 270, and then oh, not too good at drawing with this here. I'm going to try zooming in. That's a little bit better. And that's our 320 degree angle of rotation. So notice this gap here would then be 40 degrees. All right, let's look at letter B. This time we're going to go negative 110. So I'm going to draw my new coordinate plane. Again, I always start on this positive x-axis. And if I'm going negative this time, think about what's going to be different. I'm going to still start right here on my positive x-axis, but instead of going up, I'm going to go down. So I'm going to go down past the 90 degree mark. So if I go down this far, that would be 90. I'm going to keep going 20 more degrees. And then I can draw in my angle of rotation, negative 110. So I went 90, and then I went 20 more for a total of 110 degrees. When you're drawing these pictures, it's best to label them when you're done where your angle is at. Okay, last one. We're going to go positive 990. But when we just did a review, oh no, stop. I accidentally hit a notification. We saw before that our graph only went around to 360. That means what happens when we're going 990, we're going not around once, not around twice, but a little bit more than that. So what I like to do before I even start ones like this is I like to figure out, well, how many rotations am I making? So I would take 990 and divide it by 360. And when I do that, I get 2.75. So I know I'm going to go around the circle 2 whole times and 0.75 more. Now I can just do that with my coordinate plane, or what I could do is I could do 990 minus 720, because that's 2 times 360, and I would get 270 degrees. So if you don't know that that's what 3/4 of the way around is, you could always subtract and figure that out. Okay, so let's draw this. I'm going to switch colors because I got a lot of red there. So I'm going to go around once, twice, and then 3/4 for a total of 990 degrees. Okay. All right. So next thing we have are coterminal angles. Those are angles in standard position with the same terminal side. For example, the angles measuring 120 and negative 240 are terminal angles. So let's kind of look at what that description means right there. 120 would be right around here, okay? And now negative 240 would bring me down, oops, right there. Notice they end at the same place. That's what makes them coterminal. When they have that same terminal side, they end at the same place. Now you could have infinitely many coterminal angles, because what you can always do is if I have this angle right here, maybe about a 50-degree angle, I can always, I could go around this way and have a coterminal angle, a negative one. If I wanted a positive one, I could spin around a whole bunch of times and land here. So there are infinite options here, but typically what we like to look at is what is the negative coterminal angle, and then what is another positive one. So let's look at these two examples. So it says find the measures of a positive angle and a negative angle that are coterminal with each given angle. Once you get good at these, you probably won't have to draw it out, But for every single example today, I am going to draw these out. And I suggest that's what you do. If you have questions about homework, first thing I'm going to say is, did you draw it out? Because if you draw it out, it usually comes to you pretty quickly. All right, 65 degrees. That puts us right around here. Okay. I know I'm not touching the origin. You all are much better at using notability than I am. Okay, so next step, now that I've got that 65, is I want a positive angle and a negative angle. I'm going to start with the negative angle. What I can do is start here, and I can go down and around and figure out what that would be. It would be 90, 180, 270, and a little bit more. It looks like the math that I'd need to do to figure out what the measure of that blue angle is take 360, subtract 65, and then I will get my answer of 295 degrees. But notice I went down and around, okay? So it would be negative 295 degrees. That would be 1. Now I need another positive one. So let's switch colors. I already have an acute angle right here. So what I'm going to have to do is I'm going to have to go all the way around and then bump up to it again. All the way around is 360 plus the 65 more to get to that terminal side is going to be 425 degrees. Notice, to get my two answers, all I had to do is subtract from 360, and then the second time, add 360. So that's going to be the way you can do it without drawing. All right, let's look at the next one. We've got 410 degrees. So 410 is more than 360. So 410 minus 360 would give me 50. So I know I'm going to have to go all the way around once. Oops, I don't want that shape. And then 50 degrees more. So right around there. So there's my 410. My positive angle should be a pretty easy one to find. It would just be this angle right here. Okay, and we already know that that would be 50. So 50 degrees is one of my solutions. That's a positive solution. Now to go negative, I'm going to drop it down, start on this positive x-axis, make my way around. How can I figure out what that is? Well, I can subtract 50 from 360, and I'd get a negative 310. And again, why would that be negative? Because I'm going down first. All right, we're going to do one more type of example before we take a pause and switch to a second video. These are called reference angles. Okay, reference angles are going to be the positive acute angles formed by the terminal side and the x-axis. So notice those keywords. It's positive, it's acute, and it's touching the x-axis. We're going to check for that every single time. So let's find the measure of these different reference angles. Again, we are going to draw the picture, and then we can figure out our reference angle from there. So the first one is 135 degrees. So 90 plus 45 more. So this would be my 135 degree angle. And now to find the reference angle. The reference angle is always on the x-axis. It's always going to be positive, so when we write our answer, we'll make a positive, and it's always acute. So this is our reference angle right in here. To figure out how many degrees that would be, it looks like I would need to take 180 and subtract 35. And then what I get for that first reference angle is 45 degrees. That's the measure of this angle. And a lot of you probably already figured that out when you were actually drawing the angle. right, let's look at letter B. We're going to draw that negative 105 degree angle. So we're going to go down 90 and a little bit more. So there's my negative 105. And now we're going to draw a reference angle. First thing I like to highlight is my x-axis. A reference angle is always touching the x-axis. The reference angle is always acute. So when I highlight this, is my acute angle going to be on the left side or the right side? Where do you see the acute angle? That's right. It's right here on this right-hand side. So it looks like to figure out the measurement of this angle, I can take 180 and I can subtract 105 and I'll know what's left over, which is 75 degrees. Even though this angle is below the x-axis, remember our vocabulary. Our reference angle is always positive, it's always acute, and it's touching the x-axis. All right, one more. Let's find the reference angle for 325 degrees. All right, let's draw it out. 325 means I'm going to go around and land somewhere around here. Reference angles are always touching the x-axis, so it's going to be touching here. It's going to use the terminal side. And so again, where is the acute angle? Is it on the left or is it on the right? The acute angle is less than 90. It is right here on this right-hand side. To figure out the measurement of this angle, it looks like what we need to do is take 360 and subtract 325. And then what we get is a 35-degree angle. Okay. All right, so you should be wondering, what does this have to do with trigonometry? That's the name of the unit. We're going to do that in our next video.